Welcome to another video. Here I'll be solving the 2012 AP Calc BC multiple choice part of the exam. And as always, we're going to start with the no calculator portion. So let's get started right away. Number one, if y is sine cubed, then dy dx is what? Okay, so sometimes it's helpful to write it as y is sine of x cubed like this, so that we can easily visualize the chain rule. So dy dx, so we first do the power rule. It'll be 3 times sine x squared times derivative of the inside. What's the derivative of sine? That's just cosine. Okay, this guy looks like it's choice E. All right, easy first problem. Hopefully it's easy for you. Okay, second guy. The position of a particle moving in the xy plane is given by the parametric equations x of t is this guy and y of t is that guy. At which of the following points xy is the particle at rest? Okay, so we can even write this as a vector, but we don't have to. I'm going to. So if we write as vector r, okay, so we'll just put the x component of vector r is x of t, t cubed minus 3t squared, comma. So the y component of vector r would be 12t minus 3t squared. Okay, so the velocity vector is just derivative of the position vector. So we differentiate each component individually. Derivative of this guy is 3t squared minus 6t. Derivative of this guy is just 12 minus 6t. Okay. So now what do we do? Well, the particle is at rest when velocity is 0. So we want each component to be 0. Okay, so let's solve for the x component first. 3t squared minus 6t is equal to 0. When does that happen? Well, if we factor out a 3t, t minus 2 equal to 0, right? Hopefully I factored that right. So our solution on t is 0 and 2. Okay. However, we have to also have the same value of t such that the velocity is also 0 for the y component. So let's solve this equation. Remember, I just said for particle to be at rest, the velocity has to be equal to 0. So both the x component of the velocity and the y component of the velocity have to be 0. So that we already did the x, now we do the y. This should be clear that t is 2. Okay, so we can eliminate t is 0 because when t is 0, the velocity in the y direction is non-zero. Okay, it'll be actually 12. So clearly it's still moving in the y direction, so it's not at rest. Okay, so only at time t is 2, the velocity is 0 in both the x and y directions. So at which the following points x, y is the particle at rest. So we found the t, value of t. So we just plug in to here, or here even. So when t is 2, we get, so let's just do r of 2, let's say. That is 2 cubed is 8, minus 3 times 4 is 12. We plug in t is 2, right? So 24 minus 3 times 4 is 12, right? So it's minus 4, 12. Whoops. Okay. And that is choice A. That's how we solve this one. The graph of f is shown here. What is the value of integral from 0 to 4 f of x dx? Excuse me. So we had to split this integral up into integral from 0 to 2, because there's this jump discontinuity there, plus integral from 2 to 4. Okay? So we have to split it out like this. This is totally fine to do, even though there's this jump discontinuity. It's okay. There's a theorem. I don't remember the name of the theorem, but the theorem says this is fine if it's a simple like jump discontinuity like this. Okay? So integral is area under the curve. So what's the area from 0 to 2 under this curve? So if we kind of draw it geometrically, it's the area of this trapezoid. How do we find the area of this trapezoid? It's average of the bases. This base is 1. This base is 5. We average it, so divide by 2, times the height of the trapezoid, which is 2. Okay? Now how about integral from 2 to 4 f of x dx? It's the area of this rectangle. It's below the x-axis, so it's going to be negative, okay? So area of the rectangle is base times height. The base is 2. the height is what? -3. Okay? It's 3, but then remember I just said it's below the x-axis, so put a negative sign, okay? So that's what the integral is equal. So what's this? There'll be 6 minus 6, which is 0. Choice B. All right, let's move on. Which of the following integrals gives the length of the curve y is ln x from x is 1 to x is 2? You just have to remember how to find arc length. That's integral from our region of interest, 1 to 2, square root of 1 plus dy dx squared dx. Okay, so we plug in what dy dx is. What's dy dx? Derivative of log x is 1 over x. Okay, so which choice is that? That looks like choice A. Okay, we move on. Maclaurin series for the function f is given by this guy. What is the value of f of 3? So this is probably one of the Maclaurin series we know, or it's a special series. So this is a power series, so we can plug in x as 3, assuming this is convergent. The radius of convergence is in 0, meaning it converges for all x. Let's hope that is. It doesn't say that, but let's see. Okay, so excuse me, f of 3, like a function, whenever there's an x, we plug in 3. So wherever there's x in a series, we plug in 3. So it'll be summation as n goes from 0 to infinity, -3 over 4 to n. Wherever there's an x, we plug in 3. It's only at this point, right? At this place is the x, okay? This you should recognize as a geometric, let me just write the whole thing, right? Series. Okay, so how do you find the sum of an infinite geometric series? That's the first term. So the first term is when n is 0. So we get 1, because something to the 0 power is 1, over 1 minus the common ratio, which is -3/4. Okay, you should remember this. So this is just 1 over 1 plus 3/4. How do we solve that? Well, we can multiply by 4 on top and bottom. 4 over 7 is what I get. Choice C. Okay. Using substitution, u is x squared minus 3. This integral is equal to which of the following? So if u is this guy, let's immediately find du. du is 2x dx. Okay, so our integral becomes, let's worry about our limits of integration afterward. We have an x dx. How do we get that? That's du over 2. Okay, and then we still have this guy to the 5th power. That's just u to the 5th. Okay, now limits of integration. When x is -1, we plug into our definition of u. u would be 1 minus 3, which is -2. When x is 4, u is 16 minus 3, which is 13. Okay, so which one does that look like? Looks like this one, right? 6c. If arc sine x is ln y, dy dx is equal to what? Okay, so we have to implicitly differentiate here. What's the derivative of arc sine? That's 1 over square root of 1 minus x squared. All right. What's the derivative of log y? That's 1 over y, dy dx. So we simply find dy dx by solving for it. We multiply y on both sides, so we get y over square root 1 minus x squared. That's the y. Okay, so that's A. As simple as that. Okay, I believe I did this problem in the AP Calc AB video. I don't remember, so let me just do it again. Tank consists of 50 liters of oil at time t is 4. Oil is being pumped into a tank at a rate r of t, where r of t is measured in liters per hour and t is measured in hours. Selected values of r of t are given in the table above, here. Using a right Riemann sum, so we're going to use, let's underline that, with 3 subintervals, and from the data from the table, what is the approximation of the number of liters of oil that are in the tank at time t is 15 hours. Okay, so to approximate integral from 4 to 15 of r of t dt, we're going to use a right-hand Riemann sum with 3 subintervals. Okay, conveniently they give us the 3 subintervals. So we're going to use, so this would be 1, this would be another, this would be another, right? Now we are going to use right endpoints, right hand Riemann sum. So it'll be this point, this point, this point. Okay, that we're going to take the value of r. So remember Riemann sum, we're just adding areas of rectangles. So area of rectangle is base times height. What's the base? It's delta t, which is 3 in this first one. 3 times f of 7, okay? Because we're using the right endpoint. The height of the rectangle would be f of 7, okay? Plus here would be delta t, is 5, right? So you have to be careful it's not equal sum intervals, so that's why I'm doing it one by one. This one was a difference of 3. This one's a difference of 5. So it'll be 5, and then we use the right endpoint, so f of 12, plus here, delta t is 3. Then we take f of 15, the right endpoint, okay? So this guy would be what? 3 times what's f of 7, 6.2, plus 5 times 5.9, plus 3 times 5.6, all right? What is that equal to? That's 18.6 plus, what is that? That's 25 plus 4.5, so 29.5 plus, this would be 15 plus 1.8, so 16.8, if I'm doing it in my head correctly. So this is what? This is what? This is almost 30, so this is, if we add 30 to this, that'll be 48.6, but we subtract 0.5, so 48.1 plus 16.8. That is now, we get 64.9, all right? This is the net change from 4 to 5. This integral, remember, integral is net change. We initially already have 50 liters of oil at t is 4. So between 4 and 15, there's an additional 64.9 liters. So 64.9 plus our initial of 50. What is that? That's 114.9, right? So the answer is C. Okay, so don't get fooled by this choice. We weren't finished it. This is the net change from 4 to 15. At time t is 4, originally there was already 50 liters, so we add the 50 back in. Okay. Which the following series converge? Okay, so, okay. This first one, you can watch my techniques for testing series and which test to use. That's in my actual UCI Math 2B playlist probably, so you can look there. This one, if we go down that sheet that I wrote, you should immediately see that, oh, we have a factorial and even exponential. So a good candidate is the ratio test. So if we do the limit as n goes to infinity of a sub n plus 1 over a sub n, so it'll be 8 to the n plus 1 over n plus 1 factorial times n factorial over 8 to the n. Okay? I'm just doing what the ratio test tells us to do. A sub n plus 1 divided by a sub n, or multiply by the reciprocal of the original guy. Okay? Limit n goes to infinity. When we simplify, 8 to the n plus 1 divided by 8 to n, we're left with 8 on top. N factorial and n plus 1 factorial. Remember, n plus 1 factorial is the same thing as n plus 1 times n factorial, so we still have a n plus 1 at the bottom. Okay? As n goes to infinity, this is 0. This is less than 1, so this is convergent by the ratio test. Okay? So this is good. Okay? How about this one? Again, there's a factorial. We can do the ratio test. Immediately, I already know what the answer is, since I know that factorials are, as n gets bigger, they're much more quote-unquote powerful than this power term over here, okay? Since it's not exponential. This is exponential, but same thing, okay? If you saw that this case, this factorial made it go to 0, actually. All right, so I already have an idea that it's going to diverge, but let's prove it with the ratio test. So n plus 1 factorial over n plus 1 to the 100 power times n to the 100 over n factorial. Okay, so that's limit n goes to infinity of, so this we could simplify like we did up here, just to n times n to the 100 over n plus 1 to the 100, okay? So we can even rewrite this as limit n goes to infinity, n to the 101 power over n plus 1 to the 100 power. If we take the limit of this would be infinite. Okay, so this diverges by the ratio test, okay? How do I know that this limit was infinity? Well, remember the rational function technique? This is n to the 100. If we expand the whole bottom out, the biggest degree is n to the 100, all right? So we do the degree test. Degree at the top is bigger than degree at the bottom. So obviously the limit is going to blow up because the top is bigger than the bottom. Okay, so how about this one over here? Well, the technique that we can use here is comparing it to some p-series, probably. There might be another way, but that's the way I'm thinking of right now. So we can, so this is 1, 2, 3, compare with, so whenever it looks like a rational function like this, we can compare with something like, we pick the biggest degree on the top and the biggest degree on the bottom. If we expand the whole thing out, it'll be n cubed is the biggest. Okay. N goes from 1 to infinity. Let's keep that notation good. So if we simplify, this is just 1 over n squared. So let's compare it with this, and let's do the limit comparison test actually. Limit n goes to infinity. We just take the ratio of these two. Okay, so n plus 1 over n plus 2, n plus 3, all over 1 over n squared. Okay, so this, I'm just doing the limit comparison test, as I was saying. So we simplify limit n goes to infinity. This n squared we bring up to the top, n squared, n plus 1 over n plus 2, n plus 3, okay? Again, we can do what we did up here. The biggest degree on the top would be n cubed after we expand it out. Similarly, after we expand the bottom out, the biggest degree would be n cubed. The coefficient out in front of the n cubed of the top would be 1. Okay, since the degrees are the same, we can take the ratio of the leading coefficients. Similarly, the coefficient out in front of the n cubed at the bottom would be 1. So the answer is 1. Remember what the limit comparison test says? It needs to be finite, which it is, right? And it has to be greater than 0, so it met the case. So this is conversion also, right? By the limit comparison test. Okay, so that is this guy, because we found 1 and 3 to be convergent. Okay, then let me finish these two and then I'll call it apart. We have the integral from 1 to 4, t to the negative 3 halves power dt. This is a power rule, so it'll be t to the minus half over negative half, valid from 1 to 4. Okay, so we can even clean this up a little bit. It'll be minus 2 t to the negative half, valid from 1 to 4. That's minus 2 times, it'll be half minus 1, which is minus 2 times minus half, which is 1. Okay, so it should be E. Let me double check. Yep, that's right. Okay, and then let's do this one. F is defined by this guy for all x, which of the following statements is true. So the probably intimidating part is this absolute value, but you can just see that they had to put this absolute value because of the domain. The square root, what goes underneath it has to be greater than or equal to 0, so this absolute value will make it happen, okay? Is f continuous at x is 2? It is, because it'll be just square root of 0, which is 0. Is it differentiable at x is 2? So that's actually this also. So we already said it's just continuous, so we can eliminate C, all right? And if it's continuous, then this limit would exist. So it's not equal to 0. Actually, if it's continuous, then the limit has to be f of 2, which is 0. So this we can eliminate also by the definition of continuity. Okay, so x is 2 is a vertical asymptote. We just said it's continuous there, so it cannot be an asymptote. So it comes down to differentiability. Okay, so we tried to avoid that, but in the end, we still had to solve it, okay? So is it differentiable there now is the question. So what happens as x approaches 2 from the left-hand side? So meaning values a little smaller than 2. So like, for example, 1.9. It would, well, the absolute value will make it positive again. Actually, we can even probably just sketch it a little bit. So square root of x minus 2, I know how that looks because it will look something like this. Okay, so now I just have to know, so if this is x is 2, right? What happens when x is less than 2? So I'll know graphically if it's differentiable there. So when x is less than 2, for example, when x is 1, what happens? It'll be 1 minus 2, which is negative 1. Absolute value will make it 1. Square root of positive 1 is what? So it'll be somewhere up here. Okay, so it'll probably look something like this. So clearly there's a sharp turn there, there's a corner there, so it's not differentiable. So it'll be A. Okay, so that's how I solve this, just sketching it. Okay, so I'll stop here for this part. Please like this video if you found it helpful, and please subscribe to the channel also if you haven't, and to get notified for the next part.